Okay, so let's do MVF E10. So we want to draw the surface. That's the solution set to this equation. Okay, well it leaps off the page at you that this is rotationally symmetric around the x-axis, right? So if it's rotationally symmetric around the x-axis, I get to decide, well, all I got to do is pick some half plane hinged off of the x-axis and just draw what it looks like in that half plane. And yeah, I could choose up here if I wanted to. I could choose that half plane, or more likely, I could choose this half plane here. Personal choice, it doesn't really matter. Let's choose this one here because it's, I don't know, slightly easier to deal with, I guess, whatever. So in that half plane, the point is the distance to the x-axis is just y, right? Because z is equal to 0 and y is positive, and so square root of y squared plus z squared is exactly y. Is that cool? Okay, so that means that our equation, square root of y squared plus z squared equals sine x, that becomes just, well, y equals sine x. And y equals sine x is not a bad thing to draw. And I'm going to try to, what's challenging is to draw it in this sort of angled, I mean, this plane is at an angle, right? So it's a little bit hard to, I guess I'll go ahead and draw the whole thing. Kind of like that. And there's y equals sine x. Keep in mind that's our y-axis and this is our z-axis. So y equals sine x. Is that cool? Now, importantly, critically, I have to look at the part where y is positive. I can't look at that or this or any of that stuff down there because this equation turns into this equation only on the assumption that y is positive. If y is negative, this is the wrong equation. I would need a negative y equals sine x. And that's a totally different deal. So that stuff there goes away. What we really have is just these things like that. Yeah, so exactly. So those are the little curves that I rotate around the x-axis, and the result then is I get these little kind of like these little lumps. I get a lump there, and then sort of a lump there, and then sort of a lump there. I'm not going to be able to make a decent drawing of it, right? Yeah, I mean, it's not critical that your drawings be beautiful or exactly to scale or showing the precise contours of each subtleties of each curve. The important thing here is that you show that it's a rotation of that little bit of curve and rotate it around, and then and critically show that there's a gap there, and then there's another one that where you have a little curve like that gets rotated around and etc. Yeah, is that cool?
So if you have a good curve in the XY plane, we show that, and then in the next picture we show just like the circles rotating.
Yeah, and as long as it's let's say it this way. Keep in mind that what I'm looking for is, did you understand what the answer of the problem should be? And, your talent with a pen, I'm not going to grade you on that. Then again, everyone should have at least some vague ability to draw, like I don't think I scared anybody with the brilliance of this art, right? Those are pretty bad. But nevertheless, what's important about what happens when you take these little bits of curve and rotate them around the x-axis is they form these little lumps. And that's really all that's the qualitatively important stuff here. That's what you want to make sure you can represent. Yeah. Okay, so I'm going to do 11 now, but let me stop the recording and do it as a separate.
Can I ask a quick question?
Yeah, let me just stop this first.